morning. Good Father's Day morning. Happy Father's Day to all you dads out there. Well, it's a drizzly, cloudy, not so nice day out there, but I don't complain too much when it rains, although I can't get nothing done outside, really. To tell you the honest truth, I hate hot and humid weather, and if it's in the 60s and low 70s and it's raining, I'd rather have that than to be in the 85, 90, or even higher when it's sunny. I was always that way. Anyways, I want to make a kind of like a update video. This is going to be a project, but it's not going to be part of this video here. But I just wanted to discuss this power supply, which I have all apart down here now, and I'm in the process of revamping it, as I said I was going to do. This is the one I showed you that I built at least 20 years ago out of a piece of equipment that was thrown out when I was working. And I tried getting the marker off of the faceplate using CRC contact cleaner. That didn't work. 91% rubbing alcohol took about half of it off. Goo Gone didn't work at all. And various spray cleaners like Awesome and all that didn't do anything. I put the question up on the Antique Radio forum, and some of the guys saying lighter fluid or lacquer thinner. Well, I don't have either one, but I may get some lighter fluid and try that. But what I did is I removed everything down to the board. I took the binding post off because it's not really needed the way I'm going to do this. I'm going to give you some close-ups on it. When I built this, or so-called built it, you know, I had excellent eyesight and had to have been, I'm going to probably say maybe 25 years ago, because I've been retired now since 2006. So it's 2017 now, so I've been retired 11 years, and I don't miss work whatsoever. Find plenty to do. No money, but find plenty to do. Let me get you a close-up here of what I did and what I plan on doing. I'll bring you over to the bench. Okay. On the right-hand side here, you can see my scribbling. About 50% of it came off. But I'm going to try some lighter fluid, and hopefully that'll do it. I got to just go out and get some. I removed some unnecessary switches off of here. And down below the voltage adjust control, you can see the original manufacturer there of the piece of equipment, and the little tag which says power on, that I may leave on there, and I'll probably use, I have one of those little label makers. Actually, my wife has one. The only thing, it uses those white tapes, and if you rub on them enough, the writing comes off of them. But if you don't touch it, it's usually pretty good. You can see the variac. It's 725 ohm, not a variac, rheostat. And the it's 100 microamp meter. Now, I had to think a little bit on how the hell did I read 4,000 volts on this meter here. And I looked, and I built this. 10 megohm resistors, all in series. Now, I had some excellent eyesight when I was able to, I looked at that and I thought to myself, I did that? That's when I had excellent eyesight. And this was all inside of this piece of heat shrink, which isn't the best thing to use. It was tucked in there, and none of my meters would read this. This was 100 megohms. So I was wondering, what the heck did I put in here? And then I took this out, and it was fastened to the positive of the meter right here on this little lug that I had soldered to the end of this. So it was basically a very simple setup. When I redo this, I'm gonna use this, and I'll just, before I use it, I'll check each one of these resistors, and it's going to be very hard with my eyesight now. And each one of these should read, these are all 1% resistors. Each one should read 10 megohms. Brown, black, and blue. So I'm going to use this. If any of these resistors are still in tolerance, I'm going to get a piece of Teflon tubing, and I'm going to mount that in it. I'll tell you, boy, I just look at this, and how did I ever solder that like that? That's just an example of the stuff I used to be able to do when I had good eyesight. I never used glasses. Didn't need them. Okay, so that was stuck. The front panel was over here, and that was just hooked like that. It was a simple Rube Goldberg piece of equipment. And here's the binding posts, which I figure I'm not going to use on this power supply. These are good binding posts, and I will use them in another project. So my intention is this scale here with those resistors that I just showed you, that resistor string, which is 100 megohms, will give me a full scale reading of 100,000 volts. Or am I figuring wrong? I'm figuring wrong. My math, I'm sorry, my math sucks. It sucks with a capital S. You have to excuse me because I'm telling you, this is the big hang up with electronics with me, is the damn math. It really is. I really find it very, very, very challenging. I can do a lot of things, but when it comes to math, I'm just no damn good at it. We're getting 4,000 volts out of this. My estimation, I don't have a meter that would read 4,000 volts AC, but the bug whacker put out about 4,000, 4,500 volts on here, DC, using one rectifier and a 7,500 volt 2200 2100 picofarad disc capacitor. That was the original design. It had one resistor, one diode, which is here. This is the diode that was in the high voltage power supply, which came with the bug whacker. This is the resistor that was hooked onto the high and low switch that I put in. And what this did is the switch shorted out this resistor, so it gave you more voltage. And this was all on the input side of this transformer here. And that was a crude voltage adjustment for the high voltage, because this rheostat was in this unit, and it was in the primary in the original power supply. My intention is to make a voltage doubler. Now, Doug has a video up there on voltage doubler, but I've been thinking of doing that to this here for several weeks now. And after watching his video, I said, you know what, I think I will go through and do that to here. Now, I had also tossed the idea around of making a voltage tripler. Now, this puts out, like I say, about 4,000 volts. So making a voltage doubler would be 8,000 volts. That will give 8,000 up here. But the next step over would be 12,000. And that would be beyond the range. So I think I'll just make a voltage doubler and not a voltage tripler. And I don't really need a super high voltage power supply. In other words, I could probably make a voltage quadrupler, which would give me, let's see, 4, 8, 16,000 volts. But then I don't have, these terminal strips will not support that. If you notice my original design here, and I think I'm on macro, am I? I guess so, the camera's not telling me that. But it looks like it's in focus with my magnifying glass. If you look right here, this is the ground lug. This was the positive of the rectifier, the cathode of the rectifier, in other words, the diode, the band end, that's the DC output. And I had broken off this lug when I built this, because you got a potential here of here to here to 4,500 volts. Okay? If I was to make a voltage doubler, I would have to make another, or get some kind of a terminal strip, because then you've got 8,000 volts. And I don't think this phenolic material would support it, because they're too close together. Even though I broke this off here, you still could get arcing across. It would jump from here, here, and here. Unlikely at 8,000 volts, but it could very well happen, because you've got a substantial increase in voltage. So this was fine for the 4,500 volts, but it will not be acceptable for 8,000. And I think 8,000 is a good power supply if I need to supply something. Not that I'm ever going to work on another oscilloscope, because I don't need to buy an oscilloscope. I've got enough. But never buy an oscilloscope that has no trace, because it's 9 out of 10 it's the high voltage power supply that's at fault, or the CRT. I learned my lesson the hard way. This came out of the Tektronix oscilloscope, voltage doubler. I had already tried this on here, taken the ground, let me put you on macro. Taking the ground right here, grounding it here, using clip leads, taking the positive, the AC side, I should say, and tack it in here, which is the output of the 4,000 volts AC from this transformer. This is the ground wire right here. And what I got out of this, I couldn't measure it because I don't have a high voltage probe. And I didn't take this resistor assembly here and try it in here, because it was still in circuit. It was still soldered in place in this original power supply. and put my meter on it and check the panel meter right here. But when I did that, I did get a good sized spark, but it was not a hard spark. In other words, not like a black and white television would put out. You know, it was a very thin spark with a little corona. In other words, it wasn't a very high current, but that's okay. But I have no idea what voltage is, so obviously this voltage doubler here is working. This is a voltage doubler from the Tektronix 7633 scope that I am going to be sending to the ham radio auction as parts, because I dismantled and junked the high voltage board, but I saved everything else, and including this. But if I build my own voltage doubler, rather than to use this, I can use like a couple of these type capacitors, and I'll get a little more oomph out of it, and I can still use a current limiter resistor on the output. The schematic on this shows several resistors, 33 meg I think in series, with the output lead as current limiter. So I will probably have that built in here, or I might even use this in here. So what I got to do is I got to actually, this side here is pretty clean. I just got to get this off. I probably got to get this off. And this, if you look closely, it'll say DC microamperes, but I crossed off the microamperes years ago with a magic marker. All I got to do here is just get a label maker and put kV on it, kilovolts. So there's no need to do anything else. Just put kilovolts here. So this will be 4,000, and the 100 would be 10,000. So it would be 10,000 volts full scale. So if I make a voltage doubler, whether I use this here or whether I use my own, I'll need to get another diode, because the diode for the bug whacker is rated for 4,000 volts. I also found in my shop a microwave diode, but it's only rated for 2,000 volts. So I'll need to get at least a 4,000 volt diode, and would at least have to be rated for 4,000 volts because I need a second diode to make the voltage doubler, and I'd also need to go and order. I'd have to order the diode too online. Probably eBay's my best source of stuff and quickest and easiest to use. A capacitor, because I don't have another one of these. I don't have a 7,500 volt capacitor, and I'd rather have one that's going to be rated for that. So you'd need to make the voltage doubler, as most of us know, you would use 2 capacitors and 2 diodes. So that would give you approximately double the voltage. I'm no good at math, so if you watch Doug there, Morslack's video on voltage doubler there, it's quite informative. And even that basic math, I still have an awful problem with. I've always had problems with math. It's, I just can't seem to grasp it, but it's the way he did it, it's easily understood. But if you would have challenged me right now and asked me to do it, I couldn't do it. So I estimate everything. When I build things, I estimate. This will give me approximately this. So if I use something that's little higher rated, let's say now a 4,000 volt diode. So let's say I get a 6,000 volt diode. So that should cover it. So I get 2 6,000 volt diodes instead of 4,000, and another 7,500, 1,200 picofarad capacitor, and I should be safe for that. This high voltage resistor string, not sure how I came up with that, but that's 100, that's 10 megohm resistors, that's 100 megohms. I don't have any, none of my meters will read 100 megohms. This will read up to 20 megohms. My Fluke 73, which is up on the shelf up there, which is my go-to meter, will not read anything. It reads over limit. And none of my other meters will read 100 megohms. And the only one that does is my good old Motorola that I got for 30 bucks off of eBay. I'll tell you, eBay has some good stuff, but not always pricey. I mean, not always reasonable, but quite pricey. But this one I got for 30 bucks, well over a year ago. And this will read a little bit. That's a battery indicator. It's all battery operated. And this is right on. Now, when I put this up onto the R times 100 scale, which that is one of the reasons why I bought the Simpson 260. I thought I'd be able to read high resistance with it, and I was disappointed that the Simpson 260 only goes to R times 10K. This goes to R times 100. So with that, I get a little meter movement at 100 megohms. Very, very little, but I do get it. No other meter will do that. The Simpson 260 won't. So each of these resistors will have to be tested individually just to make sure that they are on range. And to tell you the truth, I don't know if I can get my clip leads on there. All right. So if I can reuse this again, I don't have to make another one of these, because this is only quarter-watt resistors. But all it is a voltage dropper for the meter. So I can safely... This was connected to the output of the capacitor and the positive end of the diode. That went right to the meter. You got 10 megohm resistors in series. So let's say you had 10,000 volts across this. That would be 1,000 volts for each resistor. That's probably asking too much for the resistor to handle. But it may not be too much. And there again, I'm guessing. A lot of my stuff is guessing, and that's why I'm called a tinkerer. I'll be the first to tell you that. Not like a lot of guys, and they throw in all this math and stuff and heavy theory. I just haven't got that kind of knowledge. And I'll be the first to tell you, I don't brag and say I can do something when I know I can't. So the question, maybe you might be telling yourself, well, if you put 8,000 volts across 10 megohm resistors, 8,000 we're talking about, it might be a little over that because of the peak voltage. That's 800 volts on each resistor. I never advance too much in the electronics because you need to know your math. And math is very important, but I work around it. And a lot of my stuff is experimental. So the question is, I may not be able to use this, and I may have to make another string up with 1 watt resistors, which may handle 1,000 volts. Again, 10 megohms, 10 of them in series. So this string may not be sufficient to make a voltage doubler, which is going to have 8,000 volts instead of 4. So This is 4,500 volts now. It's probably going to have 45 is 90, so it'll be a 9,000 volts. So you're going to be way over here on the scale with if it's reading right. Now, this is a long video. But hey, I got to do what I got to do. If I use this guy, I had to stop and see if I was on macro. I don't want to be on macro here because I'm not getting up close. If I use this guy, I wanted to use this and have this sticking out the front here so I can stick a probe in there for high voltage, because this is already designed for 8 to 10,000 volts right now. I was going to come through this. But if I do that, I need to put the resistor string and tap it into this, which means that I have to cut into this 40 kV wire. That's what's on here. This is a 40,000 volt color TV wire, and I used to have that too. I'd have to cut into this to put the resistor string in here. That'll go from here to the microamp meter, which is 100 microamps full scale, and the meter, other end of the meter, would go to ground. It's unhooked right now. That's if I use this. I may not use this. I think I'll build my own. I just got to get another diode. So I'll have 2 matching diodes, 2 matching capacitors. It's actually going to be quite simple. Because if I use this on here, this meter with the 100 megohm series resistor string connected to here, which is shunted across the output of this, is going to pull down the voltage because this can't deliver much current. So whatever comes out of here is going to be sucked down a little bit with 100 megohms of resistance to ground through this 100 microamp meter. It's going to be full scale. The max draw would be 100 microamps because that's what this meter is. Now I would have to experiment on that, and I would do that by keeping this voltage control turned all the way down here, because this thing could slam over. Let's say one of those resistors shorted out. It could be a problem. Anyways, with this all the way up, once I establish where I want to be, I should read 8,500 to 9,000 volts peak with the shunt connected across this and across the meter and circuit, obviously, because I do need this meter to monitor my high voltage. So if I use this, this would come through this hole here. This would be sticking out like this. And I'd stick a probe in there. I haven't got anything that would really fit in there. It don't take a banana plug. It takes the oscilloscope. It's got the made for the oscilloscope. But I can find something that'll go in there. Because you don't want what was on there before, a long wire coming out. Now Dan, Cool Blue Lights, asked me what I use this for. It was an experimental project that I made years ago, and didn't really use it for very much of anything. Actually, it was more of an experimental situation, and I figured, well, what the heck? I mean, I had a bug whacker that the bulbs no longer worked in, you know, a little fluorescent black light that they have inside. And there was an old bug whacker, so I said, well, I got this high voltage transformer, and I picked this up at work, this case, which all comes apart, slides in, made quite nice. Looks almost like Tektronix equipment, but it isn't. And I said, geez, you know, I could make something out of that. So basically it was an experimental. I didn't really use it for anything, actually. And back in those days, I did a lot of experimentation, but again, making a nice long video for those of you who don't like long videos. Poor old Doug, he's got that fellow Marty. I don't know him. I don't think he'd watch my videos because mine are much, much longer and boring than anything Doug has ever put out. So I'm sure if Marty has ever watched this, whoever he is, he would not stay tuned very long. But I'm noted for making long-winded videos, so I think people have been warned about that for many years. Anyhow, and yeah, Doug, anywho. Do you say that all the time in your conversation? Anywho? I gotta pick on Doug sometimes, you know. Now, anyways, I think that's it. I'm gonna end this video. I wanted to just give you this video to show what I plan on doing. I got to clean this up. So what I'm going to do is I got to remove the fuse holder and the meter. I can do that quite easily. The meter's got a plastic knurled nut on it. I can remove this terminal strip. I put this on myself. I can remove the plastic nut for the fuse holder, which came with it. However, I cannot remove the pilot light. This was in there, and so was the power switch. I cannot remove that because there's a plastic, it's one of those plastic things that push down. It's not a nut. You cannot remove it. But if you look, it's pretty clean. So you know what? I'm gonna leave all this alone over here. I'll just remove this and the meter, and then I can get around here and clean all this off. I got to get some lighter fluid and try that. If that don't work, I put a posting up on the Antique Radio Forum asking what would be good to get stuff off of a fairly smooth, shiny aluminum panel. And I used alcohol, and this is as far as I got with that. It did better over here, but it's a mess. I mean, I got to clean this up and make it look more professional. And then I'll use a label maker to make little labels up. And I'll probably leave this tag on there because if I have to scrape it off with a razor blade and I end up scratching the faceplate. So I got to clean this up before I can do any construction. When I'm ready to make the project, I will make a video of it. I have to order another diode. I can't use the microwave diode. It's only going to be good for 1,000 volts, 2,000 volts, I'm sorry. Hang on. Here is the capacitor from one of the microwaves I junked years ago, and that's where I got the diode from. This is a 2100 microfarad capacitor, and you notice the 10 meg ohm resistor, the shunt resistor across on this little schematic near my thumb. I don't know if you can read that or not. All right, that's built into the capacitor. Well, the diode was plugged in here. Now, this is 2,100 volts, so the diode's not going to be rated for probably much more than 2,000 volts. Here is the microwave diode that was in there. It was plugged into the capacitor over here. It's got heat shrink on it, so I can't tell what the numbers are. I was told that these high voltage diodes have numbers on them, but they're not complete, so you have to kind of like decipher what they are. In other words, it's not going to be like a 1N 4007 or 8 or whatever. And then you look up the data sheet on them. But I'd have to cut this heat shrink off, which goes 3/4 the way up to the diode all the way down to the end here. But this is only going to be about 2,000 volts. You can't use that on this 4,000 volt transformer. It's not going to last long. That's it. Oh boy. This is Father's Day. I think I'm going to try to throw this video together and try to get it up there before we go out later on this afternoon. Thank you for watching. This is a good day to work in the shop because it's not a very nice day out there today. But it's not hot. It's a little humid because of the rain, but it's not hot. I hate hot weather. Okay. Take care, everybody. I hope I didn't bore you all too much.